whether you're dealing with numbers, and we will deal a little bit with numbers with gases, or you're just kind of looking at what gases do. Gases actually, I'm going to put a gas in this box, and sometimes I'm better at drawing boxes than others, but these are my gas particles, and all the things about these gas particles we know is they're going to have a lot of kinetic energy. They're going to bounce against the sides of their container and create a pressure. They're going to take on the shape of their container and all that. But the three things we need to describe those gas particles are the pressure, the volume, the number of moles, and the temperature. So those four things, the pressure, and I usually put them in this order: pressure, volume, number of moles, and temperature. Okay, whatever that is describing that gas. Now I want to take the next few slides to kind of focus on just the pressure. What do we mean by pressure? We need to kind of talk about units and all that. But what pressure is it's a force that's being applied over a certain area. So pressure, if you were going to do a little math problem, you would measure the force and you would divide it by the area over which that force is applied. So another than force, I guess I should say, to me, I think there's different ways to look at force, but one common way to look at force is mass times acceleration. The units of force are going to be newtons, and the abbreviation for newton is an N. So force then can break down into units of kilograms mass per second squared. And I know that's a lot, and I'm just kind of giving you some background. Actually, this is a good example of where if you study physics, they definitely talk about forces and all that, and physics and chemistry definitely have some overlap. So pressure is a force per area, and force is mass times acceleration given in units of newtons. So a very common unit of pressure then, well, I should say it's not very common, would be the Pascal. But it's not very common, but it does kind of go back to the basic units of what we call international standard units of newtons per meter squared. Now, in chemistry, when we talk about gases, we aren't going to use pressures of pascals. We actually, instead of units of pressures of pascals, we are most likely going to use units of millimeters. MM stands for millimeters of what's element is Hg. That's mercury. Very good. So millimeters of mercury is a good unit of pressure. Also a good unit of pressure that we deal with a lot in chemistry are units of atmospheres. Now, if you ever have to go back and forth, and I don't think on your test, your final, you'd have to do this, but if you ever have to go back and forth between atmospheres and millimeters of mercury, they do actually have an exact relationship. 1 atmosphere is exactly equal to 760 millimeters of mercury. Okay. So this table then, and again, well, maybe you will have some homework, but probably not on your test. It has the units and what they are at atmospheric pressure, typical atmospheric pressure. So, yeah, I think, is that my last slide? Nope, not quite. Just a few more, just dealing with pressure. So would you buy this, that these, what do you think about the volumes of these containers? How would you say? They look equal to me. Very good. Now what would you say? So V is equal. V1 is equal to V2. We'll call this 1 and we'll call this 2. How's that? What would you say about their number of moles? That's a number of moles is going to be N. N equals number of moles. Well, I would say N1 is less than N2. Does that make sense? Doesn't look like there's more down here? I think so. So one of the things we're actually going to talk about is that at here where we have more moles, does this not look like it's a higher pressure? So here, what would you say about the pressure? I would say pressure 1 is less than pressure 2. Okay, very good. They're very kind of intuitive. I want to kind of mention something about the millimeters of mercury, mmHg. Hg. So that's a very common ways of talking about pressure, atmosphere, the pressure of the atmosphere in particular. So where the mercury comes in is, what is the physical phase of mercury? Maybe you don't know this, but actually it is a liquid. Old timies, we used to put liquid mercury was in our thermometers. So the way we we measure pressure using liquid mercury is this. Basically, this is a pan of liquid mercury that is open to the atmosphere. So this is, I'm trying to kind of show it open to the atmosphere. So that means that the atmosphere can pound on it, and you kind of see this pounding with this arrow over here. And as the atmosphere pounds on it, okay, it causes actually the liquid mercury to rise up, and it will establish kind of an equilibrium sort of thing. So the greater the pressure, the more that mercury rises up. And so when we talk about millimeters, of course, is a distance. So when we talk about millimeters of mercury, we are literally talking about how far up this column flows. Okay, so that's kind of how that goes. So the height of the liquid goes is what we talk about, the millimeters of mercury.